In the previous video, we talked about the intuitive definition of limits. In this video, we're going to be talking about some notation that's going to help us understand the mathematical definition of limits. And some of you may not really need to learn this for your coursework, but I recommend you watch anyway because it'll help you with getting a better understanding of the mathematical definition and, potentially in your future courses. So there's only three symbols we really need to know. For all, there exists, and implies. Okay, and it may look kind of weird with these symbols, like, you've never seen them before, but they're not too hard to understand. And the best way to understand them is through an example. So let me write that out here. So let's say we have -5, -3, -1, 0, 2, 4, 6, 2. So this is a collection of numbers, a group of numbers that we have, and we have a variable called x, and x can be any of these values. It can be -5, -3, -1, 0, 2, 4, 6, but it can't be 1, it can't be 3, it can't be -2. It can only be these values, right? So then the first symbol we're going to look at is for all, so it's written as for all. And the way you kind of understand this is you say for all x. So the way you read this is for all values of x, right? And then whatever you say next has to be true for all values of x. So for all values of x, x is an integer. X is an integer, right? So then you ask, is this true? So for all values of x, x is an integer, right? And we can see that for all the values x can take, they are integers, so it's true. So this would be true. It's true. Then let's see an example where it's false. So let's say we said for all x, x is even, right? So this is going to be false because for all the values x can take, right, not all of them are even. So -5 here is not even, it's odd. -3, -1, they're all odd. So this isn't true for all values of x, so this entire statement is false. So we would write false, right? But a neat thing you can do is sometimes you don't want to look at all the values x can take, you only want to look at some of the values x can take. So the way you do that is you say for all x greater than 0, x is even. So you would say, instead of looking for all values of x, you say for all the values of x that are greater than 0, x is even. And we can see that that means we're looking at these values, because they're all the values that are greater than 0, these are all less than 0. And we can see that all those values are even. So then now this statement becomes true. This statement becomes true. Right? So that's for all. So then the next one we're going to look at is there exists. So there exists. So this there exists is similar to for all, except instead of looking at all the values, so instead of saying that this statement has to be true for all values of x, it means the statement only has to be true for one of the values of x. So it's saying there exists a value of x where x is even, right? So it's saying only one value of x has to make this be true for this entire thing to be true, right? And this is true because you can pick one value from here that's even. So you have 4, right? So that means this thing's true. You only have to find one. It doesn't have to be true for all of them. So we know that this statement over here is true. And then next what we have is let's see an example where it's false. So I'm going to use the thing we learned down here where we don't have to look at the entire we don't have to look at all the values x can take. We can only look at a subsection. So let's say there exists a value of x that's less than 0 where x is even, right? So this right here would be false, right? Because if we look at this, so we're saying there exists a value of x less than 0, right? So that means we're only looking at the values less than 0, -1, -3, and -5, right? All those are odd, right? So there doesn't exist, there's no value of x you can pick from here that is even. So this entire statement over here is false. So then we would say this is false. Okay, so then that's for all, and then that's and there exists. And then the last one is implies. Implies, like that, right? So this one basically is says that you say something over here, and it implies that the next thing over here is true. So let's say you said x is greater than 0. So if you know that x is greater than 0, this is a fact, then it implies that x is even, right? So this is basically saying if this is true, that means this is true. And if this is false, it doesn't really say anything about this. It doesn't matter. It's only saying if this is true, then you know this is true. If this is false, you don't really know what this is. That's all this symbol is saying. So this is a case where it's true because, we saw that if x is greater than 0, we know this is true. It also tells us that x is even because all the values greater than 0 are even. A case where this will be false is, let's say we had x is greater than 0, and we're saying that it implies that x is odd, right? And we can see that this is false, right? Because let's say this is true, that x is greater than 0, right? So we're looking at all the values up here, and then we're saying that means x is odd, but we can see that these values aren't odd. So that means this is false, right? Or let me do it in red. Wait, do it in red. That means this is false, and we can't have this match. If this is true, this has to be true, and that's what this symbol is saying. So then this overall statement is false. So this overall statement is false. So these are, you don't need to know these, understand these symbols in depth. I kind of just lightly touched on each of them, but as long as you get a general idea, it'll help you with the next video.